Okay, hello everyone, I'm Khalif and today I'm going to show you how to test our website using a locus in a Python. So here we are. I'm already built a simple API that serves HTML in different size. And I have already 5 different HTML files that we are going to test it out later. And I already make a program, Python program to start our server in the local host. And I already make the locus file dot py and the monitor system to monitor our resources like the CPU memory and the other resources. Okay, just let's get started. And now I'm going to start our server using a Python. We are typing this command to start our server, and it's started. And the second, we are going to start running the locus test for the load server that we are going to use at this time. So I type this command and it will going to be started, and we can see here uh, the primary server for our simple HTML serve and the locus for our testing the load server is already running. Okay, so the third one, we are going to run the monitoring of our resources is called like the monitor system py. Okay, and right now we have the like 11 12% CPU and 63% of memory. So we are going to test it out. In this are the landing page of our server. If we click the difference endpoint for our HTML from small, medium, large, uh, X large, and XX large, it's still functional. It's not a problem at all. But we are going to test if the user is more than one. Is not like a 3 or 5, is more user that access our server or our local host, and we are see how the difference the our server to take the response to the different kind of user. So let let's get started. I already running, and this is the landing page of the locus, and we are starting to try the 100 user that access our website, and the ramp up is like a growing user per second. So if I type 1, it means that uh, 1 user per second will going to access our website. So it's like 1, 2, 3, 5, 6, 7, and so on. So if we type 10, so it means that 10 user per second will access our server. So for the fast time, I'm going to type 10, and the user maximum is the 100. So let's get started. As you can see, it automatically to generate the table of the information about our website that is being accessed by 100 user. As you can see here, 100 user, and what kind of uh, this means, like the type, name, request, and so on. So we are going to start from the type. Type is like the type of HTML process that has been used. So in in this situation, it will be a gap because the user wants to get the data from the server, and the server respond them to give the data to user. So the name is the root of the endpoints to be accessed by a user. So it's if we like going back to our server, and we if we type this, the slash API slash HTML slash small, its its thing is the name of the in information right here, and the request is like how many requests that user give to the server, and the fail is how server responds the failure of the request to user. And we can see here there is no problem at all. There is no error on the server. It's going to be all right. So it's going to be fine. So the median is the the median between the fastest or the minimum and the maximum or the slowest time response from the server, and the type of this median is a millisecond. So basically is if there is a 2000 millisecond, it basically is 2 seconds. So it's not a big deal. It's the same, is all the median is 2 seconds, and the 95% and the 99% is like 95% is the 5% of user are more likely unlucky. I mean, like the 5% of the user is accessing the server more than 2 seconds. So the 95% are accessing the server below or at the 2000 milliseconds. So it does the same to 99%. It more likely 1% of the user are unlucky. So the average is the, I don't know the differences between the median and the average, but I think it's just the same, but just a little bit different. But you got the point. And the minimum is the fastest response time from the server, and the maximum is the slowest response time from the server. And the average size is the average size in bytes that server respond to user. As you can see here, if we are accessing the large file, the server is going back or respond to user like 1.3 megabyte. It because in bytes, so it if we convert it to the megabyte, it will be 1.3 megabyte. So, and current RPS is the request per seconds that um, at the time the server are responding to the user right now. So if we can see here, the large file or 1 megabyte is sending from the server to user at the 5 requests per second. And if there is a small file that are responding to 5 requests, and homepage is 6, and so on. So the total of the RPS is like a 24.8 requests per second. So if we are running the test, the 100 user, we are getting the 24.4 requests per second. It's just like 24 to be exact. And we are going back to the resource that we are using. These are the resources that we are using right now. We are at the 13 or 14 CPU and the 64% memory. So we are going to stop here, and we are going to next test. We are in we are increasing our user to 1000, and the RAM up is 100 user per second. So let's see if there is a difference between 100 and 1,000. Let's see. Okay, it's already 1,000, and we can see the resources. It have a different. So the resources take the more CPU and the more memory. So the server is like more heavy duty right now. So let's see here. If anything else to be fail, nothing. It's going perfectly, no zero fail. So, but the difference is the median are increased. So the before is like a 2 seconds, and now it reached like a 4 seconds. And the 90% is going much larger to almost 8,000 milliseconds, and the 99% is already at the 8,000 milliseconds. And the average is going up to, and the minimum and the max is taking a much different than before. And the average size is more likely having increased too, because the order already having a increase significantly than before. So right here, if we are running the 1,000 user, it will be 150 requests per second, right? So the next, the last test is going to be 10,000 user, and the RAMs up is the 1,000 user per second. Let's see. Um, okay, so let's see the CPU. Um, yeah, CPU hits the peak of 36%, and the memory hits like 80%. It's more likely that my memory is very hard to deal right now. It's not going to be a good thing. It's not going to be a flawless thing. It's like very busy on the memory. And we can see here, still there is no fails. It runs smoothly, and the request is more likely a high pressure on the home page. And the median is significantly increased to 30,000 milliseconds, and the 95% is going to up almost at the 60%, and the 99% is already reached the 60%, and the average time is the like 33 seconds. It's very slow that you ever think, and the minimum access is the uh it's still like the same 2 second, and the maximum access that user have to wait is like eight uh 84 seconds. It's going to be slow, and the total total of RPS is 166. So the server are going to be hacking busy right now. As you can see here, the resources stake is reaching the red zone. Okay, so that is my project. If we are testing in the Locust, eh, the at the end, at the 10,000 user, my server can handle it smoothly without any failure, but the response time is going much higher than the 100 and the 1,000 user, but it's still capable of doing that. So maybe if we are going to increase until the 1,000 100,000, it's not going to be make it, but it's still pretty decent for the 10,000 user. Okay, so that's it. Thank you for listening and see you